Online, can you see the shared monitor?
Yes, we've got it.
Good. Okay. How are you? I will start now talking about forces. To know what is the force, start dealing with Newton's law, first, second, and third law of motion for you. Now, what is the force? We need to define the force to know what we when we talk about the force. It is to know that it is an interaction, just interaction between the object. Or between the objects and the bodies and the environment. For example, the interaction between the chalk and the board will give us the line because we have a friction force between the chalk and the board. If we don't have a friction force between them, then we don't have any interaction between them, then we will not see the line. Also, if we don't have any interaction between our foot and the ground, then we cannot walk. We just slide on our pace because we have an interaction force between ourselves and our environment. We can walk. This force is the friction force. Friction force in this case is good force, not bad force. But when a car moving in a way or moving in water, then we have a friction force. This friction force resists the movement of the car or the boat or any moving body. It will make us pay more gasoline to in the engine to move in the same velocity or to accelerate, then this friction force is bad. Sometimes we have good friction force, sometimes we have bad friction force. Also, we have a force acting on bodies. When we need to move body, we need to interact on it. Some bodies need to touch it. Some forces need to touch between the actor, and the body. These forces are make interaction between bodies by contacting. But for example, the gravity is a non-contacting force. There is no contact between the mass and the ground, the air, to attract it. So we have contacting force and a non-contacting force. We have also the shape for these forces, pushing force or pulling force. All of them, we need to deal with them as vectors. So the force is vector. The force is a vector. Force is a vector. We name it F as a vector, which has a magnitude, which is just number, and it has a direction. Before that, a unit. The unit of the force is Newton, and we have a direction. So, because the force is a vector, then we can write it this way: F as a vector is equal to Fx I hat plus Fy j hat plus Fb k hat. Cartesian, 3 dimensions. We have many examples of force. For example, friction force, gravity force. We have also electric force and magnetic force. Some forces have 2 directions. For example, the magnetic force. Magnetic force. We have repulsion and attraction. Also for the electric force, the same thing. But the gravity has just 1 direction force. It's just attraction force. We know that. We have also the normal force. We have also a normal force. What is the normal force? You need to know it, and you will deal with it in the lab. If we have an object on a table, what are the forces of this object? Because it has its mass, then there is an attraction force between the object and the air. Then we have the weight downward. Is that clear? Okay, now the object is in the air. Because it has its weight, then it will go down. Will it go down until it touch the table surface? What make it stop and not go down? The surface. So the surface now is fit by a force against or versus the gravity to this object. How can we understand this? If we have an object, for example, a book or something like that, I will talk about normal force. Normal force. Because this object has a mass. Note that in the previous 3 chapters, we don't talk about the mass. Now we will deal with the mass. We will use M, which is the mass. M is the mass of our object. because the body has any object has its mass, then we have gravitational force downward. This force, we can name it wave. And we will see that this wave is equal to the mass multiplied by g. G, which is 9.8. This is g. And its direction downward, which is the acceleration due to gravity. So we have the wave downward. So why is this object that doesn't go down? Because we have a surface. This surface acts by another force in the opposite direction of the wave. Because the angles are 90 degrees from the surface, we call it normal force. If the wave is 10, then the normal force is 10, but in opposite direction. In this case, the object will not go down or will not go upward. For example, if the wave is 12, I'll draw here. Now we have the force downward is 12, but the normal force is 10. What will happen? When we sit on that seat, we see that we can push it until the normal force arrives to be 11, then it will be 12. Until the normal force equal to the wave, then we cannot push the sponge more. Or if we are on the beach, that yes, we can, our foot will not die in the sand. Until it will die until the normal force is equal to the wave downward. This is the normal force. The normal force is always normal to the surface or with angle 90 degrees. If we have, for example, ram, as you will see in the lab section, and we have an object here. The normal force in this case is not in this direction, because this is not 90 degrees. The normal force is this direction. But the wave is always downward. We will learn more about it. Okay? Also, we need to know that we have in nature 4 types of forces. We have gravity, we have electromagnetic, we have the nuclear forces, which are the weak and the strong interactions inside the nucleus. We will not deal with them. We will deal with just with the gravity and the electromagnet. Electromagnet means there is atoms and particles. This object consists of them. The interaction between these atoms are electromagnetic, because we have electrons and protons and something like that. What is the contacting force between my body and between the two bodies is an electromagnetic forces. So we deal with them. The contacting forces is because the electromagnetic forces. Now, I'll start dealing with forces using examples. Again and again, if you print the lectures, it will be more simple for you. If you print the lectures, they are already exist on canvas. It will be more easy for me to write and put some notes. Now we will deal with superposition. Of forces. Superposition means adding and subtracting forces. Forces are vectors. We need to add and subtract vectors. Sometimes the vectors in the same direction, and sometimes there is an angle between them. This angle is theta. Maybe it is 90 degrees, maybe it is different than that. At first, let us look at the stationary case. We have just a mass on table surface. It has just its weight. We have just the weight downward. And we have, because we have contracting force between the two surfaces, we have normal force. This way we draw, we will see that the free body diagram. Free body diagram, we need to draw forces as vectors on our body. Okay. As we talked from before, how much the resultant vector from the two forces? Do we have any horizontal forces? We don't have in this example. We just have the weight and the normal force. And the weight is equal to the normal force in magnitude, but in opposite direction. Then the resultant force now is equal to 0. And this force in y direction, we see that we can take xy plane, this is y positive, and this is x positive. Then the total forces in vertical direction is 0. And we don't have any f in x direction. It is also equal to 0. If we have another example, if we have an object, it has its weight and the normal force, and we have a force acting in positive x direction, we can take our coordinates again. This is y and this is x. We have the first force, which is the applied force, is equal to 50 Newton. The force is a vector. It has a magnitude, which is a number, which is 50. It has a unit, which is in Newton. It has a direction, which is to the east or to the positive x direction. So we can write it in this case, F is equal to 50 I hat plus 0 j hat plus 0 k hat. Because these are zeros, we can remove them from our equation. Also, we will suppose that we have a friction force. The friction force is always in the opposite direction of the motion or the expected motion. So also the friction force is given the lowercase f. And in general, it's small. You can take it 2, 3, 4 as you want, but our example is 1.5, I think. Yes, it is 1.5 Newton, and its direction to the opposite x direction. Now I need to know that y forces. I need to add the forces in y direction together, which are the weight downward plus the normal force upward, just like the first example. Because we don't have any motion or any effect of these forces in the vertical axis, then the effect, all effect of them is 0. We can see that the body is not flying in the air and it is not diving in the ground. If I need to ask you about the normal forces here, if we have 10 versus 10, then the resultant force is 0. But what if we have 13 versus 10? The body will start flying in the air. But the cause of the normal force is the weight. Now, so they should have the same magnitude. But what if the weight is more than the normal force? The body will start diving in the surface until the two forces are the same. Now we are dealing with the forces because they are in 2 or 3 dimensions. We are dealing with them each direction alone. Then we will choose the y direction. Sometimes we call it the perpendicular direction or the vertical direction. Okay. Now, the weight plus the normal force are equal to 0. We know that they are the same, but with opposite direction. Is this understood? Now, if we are talking about the X forces or the parallel forces or the horizontal forces, okay, we have the applied. Sometimes I will put A means applied. The applied force, which is 50, applied in right direction. Plus, we have the friction force in negative X direction. It is not equal to 0. We don't know that. This equal to 0 because we study this. But what about this? We need to compute it. Okay, let us compute it now. Where is this? The applied force, how much? Is 50 in positive I direction. The friction force is plus 1.5 in I direction, but with negative sign. Then the total X forces are 48.5 in positive I direction. What we are doing now, we are doing just superposition of forces. We add forces together. We subtract forces from another force. Adding and subtract vectors, we know about them. But what about the force? We can call it superposition of forces. Let us look now also to another example. What if we have an angle? This is 48.5. Okay, what if we have surface and an object? The applied force now, not parallel to x-axis or to y-axis. This is as applied. It has an angle about the positive x-axis, which is 30 degrees in our example. The mass of this object is equal to how much? Two kilograms. We are not caring about the pound, feet, or something like that. In the future, you will see just 1 or 2 questions in the first midterm exam about converting units. But in general, that's enough. We will deal with vectors and forces and energy and work or something like that. We are done from the mathematical things in the first chapter. Now, we have also the in negative y direction. What we have? We have a mass. Because we have a mass, then we have an interaction between the mass and the air, which is the wave. We will talk about it in detail. Also, we have a normal force. Do we have any friction force? Yes, we have. We have friction force. Is equal to 1 Newton. Applied force is equal to 10. Now I need from you to find the total forces in y direction and x direction. So I will start with y direction. We have the weight downward plus the normal force upward. Is that it? Do we have any other forces? This one? Yeah, we need to compute the component. F, Y. Also, we need to find the component F, X. The Fy component is in positive Y direction. So we can put it this case. Positive Fy, which is the applied force, upward. All of this will be equal to the total forces in Y direction, or total forces F perpendicular to our system. We will see that data, or vertical. Now, okay. The weight is equal to mass multiplied by G. Negative sign, because it is downward, plus the normal force, we don't know it. It is upward. Plus F applied, which is the magnitude of the force, which is 10, multiplied by sine or cosine? Sine, because we will take cosine with the direction of the angle. Not with the x-axis, but with the direction of angle. Sometimes the angle with y-axis. Now, sine 30. Okay. I need to ask you something. Do you see that the object is moving upward and downward? I will show you something. If I have this object, here, and this is the force. The object is just moving horizontally. Or if I pull it in the same angle, which is 30, the object moving horizontally. If it is moving in this way, then we have motion in vertical axis, but we don't have. Then how much the forces in vertical direction? We will learn more about this thing. The total forces in one direction is 0. Now, okay. Now, the weight M is 2. G is 9.8. Plus the normal force. Now, the normal force is not equal to that weight downward. Okay? Because we have another acting force. The normal force sometimes not just equal the weight downward. Now we have two forces, two surfaces, the board and the eraser. Okay, we just do like this. There is a normal force between them, but this normal force is small. What if I put my finger like this? The normal force now, it is different than the first one because we have another force. The normal force changes to make the objects just touch the surface and then don't dive inside it and don't make that object flying. Okay? And that normal force now, there is no relation between it and the weight because the weight downward and the normal force is in this direction. So the normal force, you need to know that. There is no relation between the normal force and the weight. It's just between the normal force and the other forces, between the two surfaces. Now, plus 10 is 10. Sine 30 is half. Sine 30 is half. 10 multiplied by half is 5. This will be equal to X is a scale. This will be negative 19.6 plus n plus 5 equal to 0. How much n? In this case, n will be equal to negative. No, to positive because we will move this to here. 14.6 Newton Because it is positive in positive j direction, we are talking about j direction. Even it is positive or negative direction. Now, this is the normal force. What about the total force in y direction? The total force in y direction is 0. We find the normal force. What about the total force in the x direction? Don't need this. Yeah. I can't hear also. Yes, we need now to find the forces in the x component, x direction. We have two forces. Now in x direction, we have the friction force in the negative, which is central. We have negative friction force. This is equal to all the forces in x direction plus the applied force, but multiplied by cosine theta, which is the x component, this one. In this way, we will not deal with any force not in the xy or xy axis. We take that components. Okay, that friction force is equal to 1 with negative sign plus 10 multiplied by cosine 30, which is some number. How much? I have problem with my ears during this month. 25? Or you tell me all of them? All the, it is 8. So cosine theta is 866 multiplied by 10. So we have minus 1 plus 8.66, which is equal to 7.66 in newtons. It is all in its direction, or in I hand, with positive sign. Now, we have two forces. This is our object. We have x forces, Fx, which is equal to 7.66 in newtons, okay? We have y forces, which is equal to 14, Fy, which is equal to 14.6, I think, in newtons. We are done. We have two vectors with angle equal to 90. We can find, we need to find, we have to find the resultant force. Fr, for example, can be. Okay. Using the Pythagorean theorem, this is Fy equal to it, Fy. Then we can find that F resultant is equal to the square root of Fx square plus Fy square. Is that easy? What is the direction of that resultant force? I gave it the name angle phi. Okay, I can use tan inverse of Fy over Fx is equal to phi. You can write it in radian or in degree. Yes. Now we need to know how to choose our coordinates. If you see me now, I take a simple example. This is the surface of the table, and I choose this is an object, and simply this is x, and this is y. It is simple. Okay, but in the exam you will see me give me another example, which is more difficult. Maybe it is in this shape. Now we are talking about choosing of the coordinates. You can open the files. I'm sorry for the line. Okay. What if we have a RAM? Like just what you see in the lab. We have this object. Okay, this is the air. We have the weight downward. So somebody of you can tell me, I need to take, this is X, and this is Y. It's okay, there's no problem. But you need to deal with the normal force. The normal force is normal to the surface of motion. This is the normal force. Then you need, this is the angle, say, for example, because it is theta, this is theta, and this is theta. You need now to deal with the forces as you take your coordinates. It's your solution. If you solve it right way, it's okay. Another one can solve it, and maybe it may appear more simple. He take this is the body, then he assumed this is his X and Y axis. Then he has now, this is the normal force, and this is the weight. Now we need to find the components of the weight. It's the same. Okay? If you are studying physics, it's the same for you. The third and fourth year. It's okay. What if we have another surface? Maybe it is a curved surface this way. And this is the center rotation, for example. You can take, this is XY. When you move to this point, you will take, this is XY, different direction. Then you will take, this is XY in, no, this way. What? The center of this bar has a center at this point. Then you will take, this is XY. Then our coordinates will change with respect to our system, to our problem. Okay? Because we have curved system, then we have curved coordinates like spherical and cylindrical coordinates. We can deal with this simply. Sometimes, if we are dealing with the wall, like this, or like this, or where is the perpendicular coordinate? Where is the horizontal coordinate? This is the wall, and we have a ladder, for example. And the ladder is sliding like this. Then we can take simply XY plane. This is Y, and this is X. X in this case is a perpendicular. Y is parallel. You see, we solved that X is parallel and Y is perpendicular. But that is with respect to our coordinates from the beginning. But in this case, we can change. It is your problem. Okay, it is your solution. You can put what you need to put. How can you know that is right or wrong? Maybe you will discuss that with your classmate or with me. And in general, it's okay if you go through logical steps, everything is right. Then, okay. There is an example, long one, for a boat going down this level with angle theta, and we have mass. The mass M, the mass I think is 100 kilograms. We have a weight downward. We have a normal force. Do we have any friction force? No. We don't have any friction force, but we have a wind force. We have wind, and this boat has it's got what's the name of these things? Sails. Okay, thank you. We have the force of the wind is equal to, which is F applied, which is equal to how much? In the example, maybe it is 1,000. No, we need to find it. Now, in the normal cases, we have this surface and we have the boat. Then the boat will go down. But if we have a force keeping this body, it will not go down. We need to compute this force. Okay? Now we need to suppose our XY coordinates. I will take this system. I will take X parallel to the motion, to the surface of motion, and Y perpendicular. Then I have total F in Y direction equal to something, and I have also total Fx is equal to something. If my boat is stationary at this point, how much the total force is? This is the eraser. Now, this is stationary. How much the total force is on it? In X direction, how much the force is? We don't have forces. In Y direction, we have the weight and the normal. The total forces are 0. So this is balanced case. We will deal with this with the Newton's first law. We will talk about that. So we have the total F in Y direction are 0, and the total F in X direction are 0. Because the boat is stationary. Now, what are the forces in Y direction? It is the same way. Now, if you look, we have the weight downward. We have, this is the angle theta, this is theta also. So we have on the negative y-axis weight component, which is weight, sine or cosine? Sine, because it is y, or cosine, because theta is about the y. We have theta about y, then cosine with the direction of theta. Cosine theta. When we draw this way, we have theta in this direction, this is y. We put cosine here and sine here, not because this is x, because theta from the direction of this axis. Now we have theta from direction of negative y-axis, so we will give it cosine theta. In this direction, it is the weight sine theta. We have the normal force on positive y direction. We have the wind force, it is in positive direction, this thing, this direction. This is the applied force. Because this is theta, we have this is 90 degrees, then this is theta. Now we have the applied force, this is positive x. We have F applied cosine theta on x, because theta in the direction of x. We have the other component in negative y direction, which is F applied sine theta. Any question about that? Tell me, please. I will repeat it. You need to read it. I need to read it. Now, I'll repeat all of it. We have, this is the ribbon. This is theta. This is our body or boat. We have This is y axis and this is x axis. We have the wind force, which is F applied. We need to put the beginning, the start of that vector at that origin. This is theta again. We have the wave. This is theta. So we have wave cosine theta. We have F applied cosine theta. We have F sine theta from here. We have the wave in negative x-axis, wave sine theta. We have the normal force purely on positive y direction. Now we will take the y forces together, the x forces together. The summation of all of them are equal to 0. This equal to 0 means we have 10 newtons with 10, 5 with 5, 6 with 6. It's easy. 100 with 100. So, in y direction, we have 0 equal to F applied cosine theta minus W sine theta. In x direction, we have 0 equal to normal force. Sorry, this is x. This is y, right? I'm sorry for that. 0 equal to the normal force, positive direction, minus 2 forces, F sine theta, which is F applied, and minus wave cosine theta. Now we know the wave is equal to mg. It's known. So this is known. This is known. Theta is equal to 40 degrees. So it is known. Theta is known. Theta is known. Theta is known. Theta is known. We have two unknowns, which are Fa and normal force, with two equations. We can find them. We can find that the applied force, which is the wind force, is equal to, we need to solve this system of equations. Then, if applied is equal to, I will show you that if I have more time. Now, is equal to 822.32 newtons, and the normal force is equal to 1,279.3 newtons. And each one of them, we know its direction. Questions? We will move now to Newton's first law. Newton is the founder of this science in this modern way. So he is divine for us as a physicist. Now, Newton's first law is, if we have total force is equal to 0, then the object even has a velocity equal to 0, or has a velocity equal to constant, and it is just in a direction, in one direction. In other words, the acceleration acceleration is equal to 0. Always. Is that clear? Because the total force is equal to 0. So the stationary object will stay at its state. The moving, not on the ground, not here. If I move this, it will stop after a while because the friction force. But in the space, if I push any object, it will just stay move in constant speed, in the same direction. There is no change in direction. So these objects with acceleration equal to 0 obey Newton's first law. The law of balance or equilibrium. It is Newton's first law. We don't have any forces. If we have a circular motion with speed equal to 5, constant, okay, we have acceleration now. Because the object changes its direction, then we have acceleration, which is a radian, as we see from before. So we have acceleration, so we can't apply Newton's first law here. But we apply Newton's first law in this case, because we have balance or equilibrium. What if we have change in velocity or change in direction? Then we will talk about Newton's second law, which is the most important law. Okay. Newton's second law until this point, we will not deal with the mass. We deal with it here by computing the wave. Now, in Newton's second law, I need to do some experiment. I need this and this. Simple. Which mass is bigger? It's clear. The fan has more mass. If I apply now a force equal to 3 newtons, like this, the small mass will accelerate in acceleration, some acceleration amount. The acceleration is a vector. The acceleration is a vector equal to number and direction and unit, which is meter per square second. If I apply the same force on this bigger mass, it will not accelerate and move just like this one. So there is a relation between the force, the mass, the acceleration. This relation is the Newton's second law. Simply, F applied is equal to the mass multiplied by the acceleration. You can see in the the next page. Now, the force is the acceleration is a vector. The mass is not a vector. It is just a number. We multiply a number by a vector. We give us a vector. So the direction of the force is the direction of the acceleration. If we have 10 newtons and the mass is 2, how is the acceleration? 2 multiplied by will be equal to 10. How much? 5. Okay, if I magnify the force, which is I make it 40, is equal to The mass is the same. How much the acceleration now? 20. That means the accelerated body will move faster than the first one because the force is bigger than the first one. And the direction of this motion to the direction of that force. What if I have XY direction and I have an object at the origin and it is moving to the positive X direction? It has velocity. And I apply a force in positive X direction. What will happen for this velocity? Is it bigger, the same, or smaller? It will be bigger. If you are moving your car with velocity 10, 20 miles per hour and give it more power, you will make the engine give the wheels more force. Then the car will start accelerate and its velocity will be bigger. If I give it the force in the same direction, then the velocity will be bigger. If I give it a force in the opposite direction, this is the same like this. Maybe it is a friction force. If you remove your foot from the accelerator, then that velocity will get smaller because you have an opposite force. So when V2 bigger than V1, we have acceleration. This acceleration is positive acceleration. When we have V2 is less than V1, we have negative acceleration or deceleration. Okay? Another thing also, what if we have, so the force will change the velocity of the object. If the velocity of the object was 0, then later it will have a new velocity. Now, the force changed the velocity of the object. We know that. What if the object moving to the positive x-axis and the force coming from upward? What will happen for this object? Like this. I have a moving object and I put another force. The object will change its direction. Is that clear? Because we have a force not in the direction of the velocity. So it will change the direction of that velocity, whatever that direction was. So the effect of the force in physics, it will change the velocity and it will change. When we talk that it will change the velocity is the speed and direction. It will change the speed and or will change the direction. This is the effect of force on any object. If you told me we have this object, piece of sponge or clay, this is it. Then I apply a force. It will not move. It will be compressed. Yes, the force changes the velocity of these particles and the direction of their velocity. They are moving. So this is the effect of the force. It will change also the shape of the object. We need to apply examples. By the way, chapter 3 homework is ready, as I sent you the email and the video of the tips to how to solve that homework is existing. You can start doing it. And I have an important point for all of you. I need to know if the lockdown browser is working or not. I know that all of you, maybe more than 90%, are finished their quiz using lockdown browser. But there are 3 or 4 or 6 students I need from them to know about this or to tell me what we need to do. We will solve it. You will take the exam. We have this example. Okay. We have a mass. This mass, we have 3 masses, by the way. 5 kilograms and 10 and no, 2 the second one. 2 kilograms and 10 kilograms. We have the same force. 10 newtons, 10 meters, 10 newtons. We are not caring about the number because the way is just to use the formula, which is F equal to ma, for m equal to F as a magnitude over acceleration as a magnitude, or the acceleration is equal to m over a over m. We sometimes we write this triangle, which is F M A. M A is equal to F. F is equal A is equal to F over M and so on. How about the acceleration in the first one? It is the force divided over the mass. In X direction, all the motion in one direction now. We will deal with the motion in 2-3 dimension now. The acceleration will be 10 over 5, which is 2 meters per square second. Here, 10 over 2, which is 5 meters per square second. Here will be 1 meter per square second. This is the acceleration. Now, if we need to look at the units, Newton is the unit of the force, which is equal to unit of the mass, kilogram. The unit of the acceleration is meter per square second. So if you see this unit or this unit, they are the same. What is the Newton? It is kilogram meter per square second. But it's not logical to write it always kilogram meter per square second, kilogram meter per square second. And there is a great man named Isaac Newton. You need to give him something to be happy. Now, another example using the X, Y, Z direction. But we will deal with just 2 directions. And all of the other examples in 3 dimensions will be the same. In XY direction, now we have another example. We have F as a vector is equal to, we know that Fx I hat plus Fy j hat plus Fc j hat. The mass is equal to a number for all the directions. We have the acceleration vector also equal to Ax I hat plus Ay j hat plus Az j hat. We take it from before. What if we just multiply A by M? In different way than here. That this one is equal to F as a vector. This component will be equal to Fx. This component will be equal to Fy. This component will be equal to Fz. If we have in our example,
a mass M equal to 50 kilograms. We have two forces. We have F1. No. We have also F2. F2 is equal to 50 in newtons, and F1 is equal to 20. Again, we need to deal with the vector. We need to put the start of that vector at that origin. So this is F2, and this is F1. This angle is equal to, I think, 40. This angle is equal to 45. Is that right? Okay. Now, I need to know Fx, Fy, and Ij direction. We don't have Z direction. So I will remove them from here because I have them here. This is 40, and this is 45. I have components. For F1, I have here F1 cosine 40 because I have 40 from the x direction. I have F1 sine 40 because the 40 is from x. Now here, this is 44. 45. And also this is the same. This will be equal to F2 sine 45. This will be equal to F2 cosine 45. You know cosine sine 45 is equal to cosine 45, which is equal to 1 over square root of 2. This is in the middle. So the x components of the forces Fx is equal to both of them in positive x direction. F1 cosine 40 plus F2 sine 45 will be equal to F1 how much? 20 cosine 40 plus 50 sine 45, which is equal to how much? It's 50.68 Newton. It is positive, means the positive x-axis. Fc, Fy, I'm sorry, which is equal to positive F1 sine 40 minus F2 cosine 45, which is equal to 48.21 newtons. We find the forces. We can write now the force vector. We can compute the acceleration also in x and y direction. So we need to find Ax, which is equal to Fx over the mass. Ay is equal to Fy over the mass. This will be equal to 50.68 over the mass, which is 20. Over the 50. This will be equal to 48.21 over 50. This is the acceleration. Then we have two vectors. F as a vector is equal to 50.68 I hat plus 48.21 j hat. The acceleration vector is known now. We can find the object any time. 1.01 I hat plus 0.96 j hat. Now we have two forces. We have two acceleration. We have Fx, Fy. AY, AX. Our brother in a different color. AY, AX. They are in some angle. And the force, this is F total. This is the acceleration as a vector. How we can find F total is equal to Fx squared plus Fy squared. The acceleration as magnitude is equal to Ax squared plus Ay squared. The angle phi. This is phi. Phi is equal to tan inverse for Ay over Ax, which is the same as tan inverse of Fy over Fx, because they are in the same direction. But there is a scalar product, which is the mass. Any questions?
Tan inverse y, and then the tan inverse of my, those will be different numbers, right? No.
Because they are in the same direction.
Oh, same direction.
Because if you take the opposite, this is Ay over the adjacent Ax. For the other case, this is Fy. This is Fx. I'm sorry. So Fy over Fx is tan phi, not theta. Because theta, we use it before. But phi for the result. Okay? Which is the same. Ay over Ax is tan phi. They are the same. The difference between them, or the ratio between them, is the mass. So the acceleration is equal to, or the force is equal to the mass multiplied by the acceleration. They are in the same direction. For example, small one. If the acceleration is equal to 2 and the mass equal to 3 and the direction of the acceleration 1, 2. This is the acceleration. How is the force? The force is equal to mass multiplied by 2, which is 3 by 2. So we have 3 accelerations. This is the first acceleration. This is the second. This is the third. We have acceleration equal to 2. The mass 3 multiplied by 2, which is 6. Now this is the force, which is 1 kilogram, 2 to 3 kilograms, 3 kilograms multiplied by the acceleration. Maybe the mass, if the mass is half, then the force will be half of 2. This is the force. It's a multiplication of vectors. We'll do that many times in the lab. I think we are done today. If you have any questions, please email me. And we have office hours tomorrow and the day after. And in general, I cannot bring these with me always, but I need to show you that. Okay, online. Any questions?
thank you.